Hello again. I just wanted to remind you that our textbook for at least my section and Dr. Karen's can be found at www.openstacks.org. And if you go to subjects, go down to science, and then you'll find chemistry, second edition, atoms first, and you will be able to download the PDF of our entire textbook for free. Later on, we will all be sending information about how to order textbooks, but for right now, you have access to the textbook that we'll be using for my section and for Dr. Karen's section. For those who might be in Zwier or Bojorka's section, again, I would advocate that you still download this book and at least get the sense of how to deal with the college textbook and how to read it by watching these videos. You'll have a different textbook, but the ideas will be largely the same. So with that said, after the last video, I challenged you to then now read the next section about significant figures and calculations and figure out how to do those things. Now, what I hope you've done is read that section, read the examples that are in it. Did you skip the examples? If you skipped the examples, you skipped all of the important information. So again, the expectation is that you are reading the material that is in the book and drawing information out of it. And then at the end of that section, so here's example 1.4 about addition and subtraction of significant figures. And then the next section is multiplication and division, and then calculations with significant figures being exemplified in the next couple examples. Okay. So just like figures are worth 1,000 words, these embedded practice problems is where a lot of the information, the application of the principles gets done. So again, most college tests aren't going to just be testing you on the definition of something. The expectation is you're going to know the definition and, more importantly, know how to apply the concept that that definition pertains to. So with that said, the first part of this section was about significant figures and just defining how to round. So I will leave that to you to read and when to round up or when to round down. We tend not to get too wigged out about the rules of when it's exactly 5 at the end, and then you got to look at the digit before that and decide, do you round up or do you round down? There's a lot of machinations there. But for the most part, we would very much expect you to be able to look at these kinds of problems, 31.57, and round it to 2 sig figs. Okay, well, if I want 2 sig figs, I'm going to be rounding to this decimal place. And then 0.57 is more than halfway past 31, so this would round up to 32. And be able to go through those types of reasoning skills. All right, the 3 sig figs, so that would be 1 to this decimal place. So 49 is less than that 0.5, so this would round to 8.16. Okay. So hopefully rounding is something that you've done already. Now, what gets more confusing is when we have problems where we have different numbers of sig figs in the numbers that we're adding, subtracting, dividing, and multiplying. And students get very confused by this. And I would argue that there's really not a very good reason to be confused by this if you take your time, look at examples, and think for yourself about why the rules are what they are. Okay. So this is something that if you just kind of want to go, oh, well, it's confusing and I don't care and I'm just never going to get it, you have that choice, but with a little bit of effort, and by the end of this video, you'll understand what I mean with that little bit of effort, you'll be able to get all these problems right. I see so many students losing points on exams on things that with a little bit of time, little bit of care, could be easily understood if you just take the time to do that. So here we have a problem. Notice there's no text about this other than this problem. There's not a section that says adding and subtracting with significant figures or multiplying and dividing with significant figures. The expectation is that you are working these examples that are embedded in the text. Okay? Not skipping over them, not skipping over the pictures that are given. Okay? So rule, when we add or subtract numbers, we should round the result to the same number of decimal places as the number with the least number of decimal places. That's the rule. Very simple rule. So we look at this number and we ask, how many decimal places are there? Not significant figures, right? So here we have to get a little precise in our terminology, and that is often something we tend not to like to do, but it's necessary in the sciences. We're no longer talking about significant figures here. We're talking about the number of decimal places. So how many decimal places are in this number? Well, there are 4 decimal places. How many decimal places in that number? There are 3 decimal places in that number. What's the rule then when we add these two things together? We're going to round to the same number of decimal places as the number with the least number of decimal places. So we are going to round to the same number of decimal places as the least. We're going to round to 3 decimal places. That's literally what this says. So when we do that, we have 1.0023 plus 4.383. When we add these two, if we were to take a calculator out, this is what the calculator would show us. But now we have to say we're going to round to the least number of decimal places that we saw. We saw that 3 decimal places is the least number of decimal places that we have. We're going to round this to 3. So that 3 decimal places, 3 is less than 5, so this is going to stay as a 5 when we round. Okay, so the answer would be 5.385. So notice, even though there's 3 decimal places, the answer has 4 significant figures. So we're differentiating here between significant figures and decimal places in the rule for addition and subtraction. And notice something like 90.38 plus 12.52. Both of those have 4 significant figures. But this rule doesn't say anything about significant figures, does it? It focuses on decimal places. If we were to add this, we'd get 0, 5, 6, 7, 8, 9, 2, and 102. And the rule says round to the same number of decimal places as the least number of decimal places in either of the numbers that we've added. Well, both of these have 2 decimal places, so we're going to round to the second decimal place. There is no rounding to be done here. We've already got 2 decimal places, so we're going to leave it as 102.90 because it's already rounded to the 2 decimal places. If we had a 3 here, let's say, and that would carry down, then because this only has 2, we would lop off that 3 and we would round to 102.90. But notice what's happened. Even in our first example, we had 4 sig figs there, 4 sig figs there. How many sig figs does our answer have? It has 5. So it is in fact the case that when we add or subtract numbers, we can gain or lose significant figures. We're paying attention to the decimal place. Okay. So, here's a good example of that. We're taking 486 and subtracting 421.23. How many decimal places does that number have? Not really a trick question. It doesn't have any decimal places. The decimals right here. There are no digits reported beyond that, so there are no decimal places. Here we have 2 decimal places, so the least number of decimal places is 0, so we're going to have no decimals in our answer. And then we start with 486 minus 421.63, we get 64.77, but we're going to round that to no decimal places, so it rounds up to 65 grams. So we started with 2 numbers. This one had 3 sig figs, this one has 5 sig figs, and we're ending up with just 2 sig figs. Okay. So when we add or subtract, we can actually change the number of significant figures because it's the decimal places that we're paying attention to. How does that contrast with multiplication and division? When we multiply or divide numbers, we should round the result to the same number of digits as the number with the least number of significant figures when we multiply or divide. So now they go through a couple examples here. We're going to take 0.6238 divide by 6.6. 6. How many significant figures are in this number? Hopefully you set 4. The leading 0 is a placeholder. It just tells us the magnitude of the number, so that is not a significant number. That goes back to the last section, which is why I think it's important that if we don't understand or if we get things wrong in the previous section, that we don't go on to the next section right away. Because notice that those rules come back in later material, and that's often the case in chemistry. So here we have 4 decimal places, here we have 2 decimal places. This rule says that when we multiply or divide, so we're going to here multiply, we should round to the same number of digits as the number with the least number. So what's least between 4 and 2? 2. So we're going to round the answer to 2. So we just type this into our calculator and we get all these digits, but we're going to round to just 2 significant figures. Notice here, we don't care about the decimal places. Okay. So yeah, you can say it's confusing. Oh, addition and subtraction does the decimal places, multiplication and division does the significant figure. Man, that's what it is, right? And in the end, it really isn't that confusing. You do some problems, you get into the habit of learning those rules, applying those rules. Right? Think about how complex the rules of any sport are, or think about how complex the rule of any video game is, or even just how complex the rules of Monopoly are. And you learn them. So you can learn chemistry rules too, just as easily. And how'd you learn Monopoly? You played it a lot. Or whatever game you like, or whatever video game, your telephone number. You didn't sit down to memorize your telephone number. We might not even know our telephone numbers anymore. Address, street address. You don't sit down to memorize. You just say it a lot. Right? Same thing, practicing problems. But the big point here is that these were embedded. There's no bold-faced text or anything that says this is important. And yet the expectation in my class is that this stuff gets learned on your own. If you're in my section, you can go to Blackboard and you can see the notes. And I will even say, I'm not going to lecture on rules of significant figures, how to count them, how to add or subtract, multiply or divide them. I expect you to learn that on your own. And we're going to start with chemistry-based material about atoms and molecules pretty quickly. Okay. And then in the spirit of this video, after this video ends, I would encourage you then to read through example 1. I'm sorry, I should stop. What would we want to do now? Now that we've learned the rules for addition, subtraction, multiplication, and division, educationally, what would be the best thing we could do to cement that information? Go to the back of the chapter and do some more problems. And in fact, the other thing that I would note that I failed to note in the previous video, notice here they have these little check your learnings. So they've got worked out examples up here, and then they say right away, check it. Right? They're giving you the opportunity to say, did you get it? And if you didn't, guess what? The information that you need to get it is right up above. So it's super efficient in how this is laid out. It's beautiful. You don't have to go to a website. You don't have to Google it. It's right there, right above it. Okay, in a free PDF, downloadable. You can carry it on your cell phone. You can read atoms first, wherever you want to go. And then they give you the answer. So everything you need is right there on that page. And then we go to the next page. I'm sorry, we want to go to the next page. Where would we go from here? That's right, to the back of the chapter and try some problems related to addition, subtraction, multiplication, and division. So if we turn to the back. And then the other thing that I want to point out, notice that the back of the chapter where they have problems, 1.3, physical and chemical properties, 1.4, measurements, 1.5, the section that we're currently working on. So every section in the book has a corresponding section of problems at the back of the book. So you really don't even have to search for the problems. They're telling you these correspond to this section. So if you get a problem incorrect here, when you check it in the back, then you know the section that you have to go back to. Limited 2 or 3 pages that you can go back and probably find the information that's relevant. Okay. So be clever and smart about how you use the book. And again, proceed, read a section, do the problems that are embedded in the book, do the problems at the end of the book. And as you progress through the week, you'll be building up your knowledge. And then for my section and for the other sections, we use an online homework system over the weekend Do those homework problems. Test whether or not you can do those problems without looking back in the book, because that will simulate, can I do them on an exam? I personally use a lot of textbook problems and the online homework problems on my exams. I'll take them verbatim and put them on my exams. And people will get them incorrect. And you've had the opportunity to work them already. So I really hope you take this advice to heart. It does take work. I'm not saying this is easy. It's not easy. It's work. Education is work. But the learning that results, the learning is where you get the big payoff. And it's a slow process. So I'll talk more about learning in the next video that's a little personal to me, just to say, you know, that we're in this together in this learning process gig. So a lot of my advice is not just, you know, from sitting on the professor side of the desk, it's from sitting on your side of the desk. So I'll talk about that in the next video for a little bit. I hope this video helped. That's the last one I'm going to talk about on reading a textbook, but I hope you continue through chapter 1. And since there's a lot of summer left, chapter 2. And if you do that and you really understand that material well, you're already 2 chapters ahead of the game when we start this semester. So that would be great. But take your time to read it well and do that stick-to-itiveness that I talked about in the last video, where you hold at bay the impatience that we have about education, the unrealistic expectation that everything should be easy and fast when it comes to learning chemistry. But yet we're perfectly patient to learn the rules of Monopoly or how to ride a bike or how to, you know, do some hobby. Okay, so with that, I'll stop. Hope this was helpful, and I hope you have a good rest.